Hi everyone. Let us continue with the discussion on the chapter motion. What we find is in between in the lesson, we find few questions put in there in the textbook. We need to discuss them, not in very detailed way, but just briefly. Now, few of the questions are: distinguish between speed and velocity. Under what conditions is the magnitude of average velocity of an object equal to its average speed? What does then the odometer of an automobile measure? What does the path of an object look like when it is in uniform motion? During an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at the speed of light, that is 3 to 10 to the power 8 meter per second. Well, the first question, let us concentrate on that. Distinguish between speed and velocity. So I put up a table here for our discussion. So speed on our left and velocity on our right. The first thing is speed is a scalar quantity and velocity is a vector quantity. Now, what is a scalar and vector? We have not discussed this in our lesson yet, but it is an inseparable part of this lesson's discussions. What it is mentioned in the second point. Let's go to the second point. So together we'll discuss first and second. Speed has only magnitude or the value, whereas velocity has both magnitude and direction. See, scalar is a quantity which has only value. For example, we are talking about mass of an object. We can talk about distance traveled by an object. These are all examples for scalar quantities. These quantities, we only mention the value or magnitude of the quantity. We do not give importance to the direction. Whereas on the right side, we are speaking about velocity being a vector, means it has both magnitude and direction. Example, we are talking about weight. Weight, we will have to say in which direction, because in the direction of the gravity or the pull of gravity, it is always positive. If you are considering against gravity, then it will be negative. So it depends upon the direction. Even velocity we have discussed in detail that it changes with direction. So both magnitude as well as direction is important for these quantities. Acceleration, for example, is also another quantity. These are all quantities which depend upon direction. One more example is momentum. We will discuss later in later classes that the product of mass and velocity, it is called as momentum, which also comes under vector quantity because direction becomes important in these. Anyhow, I hope it is clear that there are two types of quantities. One which depend only on the magnitude or value. They are called as scalars. So speed is one of them. And velocity being a vector. Vectors are those which have both value and direction. Coming to the third point, we see the difference in the formulae. That is, speed is the rate of distance traveled, whereas velocity is the rate of displacement. So distance traveled, we have seen that all the path that the object travels is considered, whereas displacement is the shortest distance between the initial point and the final point. So formula for speed is distance traveled by time taken. And I have mentioned earlier also in the lesson that anything divided by time taken we call as rate. So when displacement by time is there, we don't say divided by time, we say the divided by time is taken as rate. So we say rate of displacement. So that is the main difference between speed and velocity. There are, however, further discussions, but here we are talking briefly. So let me end the answer for this question. Let's go to the next question. The second question, under what condition or conditions is the magnitude of average velocity of an object equal to its average speed? So let's go for the answer. When a body undergoes motion in a straight line, that is linear motion we can call it, or motion in a single direction. So at that time, the average velocity and average speed both are same. See, to understand this, let us take an example. A body is moving along a straight line AB. Let us imagine a line AB, A at one end, B at another end. Let A be the initial point and the final point is B. Okay, it covers in 10 seconds. Then the length of AB being 40 meters. So you can draw in a rough page a straight line called AB. A being the initial point, B being the final point, and the distance between the points A, B is 40 meters, and it is connected by a straight line, and the body takes 10 seconds to complete it. So let us write the solution for this. So first is distance traveled, that is from A to B, the path covered is 40 meters. The displacement is also 40 meters. Why? Because the direct distance or the shortest distance is a straight line from A to B, which is 40 meters. So in this case, both the distance traveled and displacement are same. Time taken 10 seconds, of course. It is directly given in the question. So let us calculate first the average speed. Average speed is given by total distance traveled by total time taken. What is the total distance traveled in this case? 40 meters, of course, and divided by time taken, which is 10 seconds. So 40 divided by 10, which is equal to 4 meter per second. See, if you have observed the units of distance traveled, it is written in meters, displacement in meters. If it was in kilometer, first our duty is to convert it into meters, because it should be in international system or Sistema International. It is called as SI unit. So talking about time, we could have written it in hours and minutes, but we will have to convert everything into seconds and write it for solving the problem. Now the SI unit for speed is meter per second. So answer is 4 meter per second. Let us now go for average velocity. Velocity is however given by the total displacement divided by time taken. What is the total displacement? It is the shortest distance from A to B. The initial is A, the final point is B. So distance from A to B, that is again 40 divided by time taken, which is 10. 40 by 10 again, once more we get the same answer, 4 meter per second. So comparing both, we can directly see that both of the answers are same. Why did this happen? Because the objects moved in a straight line. So that is why both average velocity and average speed both are equal. We could also put the same answer in other words, like when is average velocity and average speed same? That is when the total distance traveled is equal to total displacement. See, from the answer it is highly clear. See here, distance traveled is 40 meters, displacement is 40 meters. This is the main reason why these two became equal. Okay, let's go to the next one. Third question is what does the odometer of an automobile measure? Okay, now here we are talking about a device. Odometer is a device which measures the distance traveled by an automobile. So in countries like India, we measure it in kilometers. So this device will show us how many kilometers we have traveled. The initial reading of odometer is noted down. Imagine we are starting a trip. Okay, we are going on a trip, and the starting reading is taken. Maybe it is written as 1000 kilometers. So we note down it as 1000. That is the initial reading. Then we go on the trip and we come back and note down the final reading. The final reading, for example, let us take it as 1500 kilometers. So the difference between the final reading and the initial reading is calculated. That is 1500 minus 1000. So we come to know that how many kilometers we have traveled. The distance traveled in this case, what I took was 500 kilometers. We can calculate. Anyhow, this odometer becomes helpful for one more device. The odometer is helpful for the device called speedometer. Now, speedometer is another device which is also fitted in the vehicles. You will see both the speedometer and odometer in the dashboard of your vehicles. Okay, it may be a bike or a car or a bus. In the speed, these two meters will be there along with the fuel indicator. These and the gear indicator and revolutions per minute indicators. All these indicators will be there. Along with that, you will find these two, odometer and speedometer. The speedometer calculates or indicates the speed of the vehicle by using the odometer. So this is what one example I have shown in the picture here. This is what you will normally see on the dashboard, okay, from the maybe bike or car. So here let us see which part is odometer and which part is the speedometer. See the top part which is separated just now, which moved to the right, which is showing us kilometer per hour. That is the speedometer. Whereas the bottom part which got separated and moved to the left, there is a reading there. The digital numbers are there that tells us the kilometers traveled. This is called as the odometer. In countries where it is measured in miles, the distance will be written as in miles. Yeah? In India, we use it as kilometers. So 201736, what you're seeing is actually the number of kilometers that the vehicle has moved. Fourth question. What does the path of an object look like when it is in uniform motion? So let us have a look at what happens to the path. The path of an object which undergoes uniform motion is always a straight line. So if it is not a straight line, that means the direction changes. If direction changes, then we cannot say that the object is pursuing uniform motion. The motion becomes non-uniform. So let us take an example of a bike here on a road. Okay. So if you observe the movement of that bike, it's going without changing its speed. And if you concentrate on the path or the road that is traveled, the shape is a straight line. So it's an easy question. So uniform motion, if a object is moving with that type of motion, what will be the path? The path is a straight line. Let's go to the next question. Last question is, during an experiment, a signal from a spaceship reached the ground station in 5 minutes. So this is the time given here, 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at the speed of light, that is 3 into 10 to the power 8 meter per second. Let us look at the solution. First, what are the given data? Time taken 5 minutes. Let us convert it into SI units, that is in seconds. So it will be 5 minutes will be like 60 seconds each minute. So total is 5 times 60, that is 300 seconds. Then speed they have already given, that is 3 into 10 to the power 8 meter per second, which is a constant value, that is the speed of light. We need to remember this for future problems. Then the unknown quantity is distance or distance traveled. So distance traveled by the light we need to calculate. The formula required is speed, which is equal to distance traveled divided by time taken. So this implies if you take the time taken from the right side of the equation to the left side, it is instead of in the denominator, it will become product with the numerator. So normally we say plain shortcut that divided by goes to the other side becomes multiplied by, right? So this time it becomes speed into time taken is equal to distance traveled. So we morphed or changed the formula for our convenience because we wanted to isolate distance traveled. We wanted to find out the value of distance traveled. So in symbols, we can write speed as v into time taken is t, which is equal to distance traveled, which is given by s. So values I am substituting here. V is 3 into 10 to the power 8 into time taken is 300, that is in seconds. I have converted them as meter per second and seconds. So multiplying both, we will get the distance. 300 can be written as 3 into 10 square. I've just written in that form so that the indices can be added up easily. Now 3 3s are product becomes easy, 9. 10 to the power 8 into 10 to the power 2. They can be clubbed together and it will be written as 10 to the power 10 by using the indices law of a to the power m into a to the power n is equal to a to the power m plus n. So the final answer becomes 9 into 10 to the power 10, but SI unit of distance is meters. So we'll write it in meters. Last, we can just write a conclusion. The distance of the spaceship from the ground station is equal to 9 into 10 to the power 10 meters.